Hello, in this video we'll be making example 2 of the plate assembly from lab lesson 4A, which consists of a top plate and a bottom plate that are fastened together by 4 pairs of nuts and bolts. So we're going to place all of these components into an assembly file together and we'll fully constrain everything. I have my parts already open in Inventor, and before we even open an assembly file, one thing I just wanted to make a note of is the appearance of these parts. You might have noticed that these parts have some pretty cool appearances that are different from the default gray that we've seen earlier. And this just demonstrates that there is an option in Inventor to change your part's material appearance. So we can simply do this in a part file by highlighting the part and going to the material appearance dropdown at the very top of the window here. And you'll see that this part just happens to be a yellow pine. I believe the bottom plate is a walnut, and the nuts and bolts are one of these steel options. So this is just something to keep in mind for other projects that you're working on in Inventor. So with that out of the way, let's open up a new assembly file. I'm going to open a standard millimeter assembly based off of what our drawing indicates. And once we have this assembly open, our first step is to place our base component, which I'll choose to be the bottom plate for this assembly. So I'll click the place button in the top left toolbar, and I'll select the bottom plate to open and place in our assembly file. So one thing I could do is I could left click to place this component, and then I could exit out of the place tool, and then I could ground this part because I know that this is my base component and I want to ground it to remove all of its degrees of freedom. Or my other option is just to right click and select place grounded at origin, and that will just accomplish all those steps in one. So now I can right click and press OK to exit out of the place tool. And now we have our base component placed in our assembly. I'm just going to change the view to be shaded with edges to maybe see things a little clearer. And one thing you might notice is that we have the square holes facing up after placing this part, which is the opposite of what we want. If we look at our drawing, we want the cylindrical holes at the top and these squares to be at the bottom of our bottom plate. So what I can do is I can use my view cube to change the current view. This would be my top view that I want. This would be my front view. So I'm just going to right click on the view cube and set the current view as front. Now this updates my view cube for me. I can also update the home view. So say I want this isometric to be my home view, then I can right click on the view cube and set the current view as home. I'll select Fit to View. So now we have our base part placed. If we hover over it, you can see the pin icon indicating that it is a grounded part. And this shows up in our assembly browser as well. We have the little pin icon here. So now we can go ahead and place our other components. So I'll click the Place button and I'll select the top plate for placement. Initially, it's oriented in the wrong direction. And if I want to change its orientation before placing it, I can right click and select one of these rotate options to rotate it about the X, Y, or Z axis 90 degrees. In this case, I want to rotate about the X axis to get the proper orientation. So now I can left click to place the part and I'll select OK. I'm then going to use the place button again to place our bolts. And these are also upside down. So I have to rotate 2 times about the Y axis. And I'm going to place 4 instances of these bolts because I want 4 for this assembly. Last, I have to repeat the process for the nuts. So I'm going to open the nuts for placing. I'll rotate them 90 degrees about the Y axis. And again, I'll place 4 because we want 4 instances of this nut component in our assembly model. So now we have all of our components placed in this file. If I go to the View tab and I turn on degrees of freedom, you'll see that all of these instances have 6 degrees of freedom associated with them, the 3 translation degrees of freedom and 3 rotation degrees of freedom, except of course this bottom plate, which is grounded. So our next step will be to remove all of these degrees of freedom by applying constraints to our assembly model. So I'm going to go to the Assemble tab and access this constraint tool. There is a shortcut to use this constraint tool, is just pressing C on your keyboard. So you can either press the constraint button in your toolbar or press C to bring up the constraint tool. So now we have our constraint tool open. So the first thing I'm going to do is constrain our top plate to the bottom plate, which is our grounded part. We know that we want the bottom face of our top plate touching the top face of our bottom plate, so those two faces will be mated together. So the first constraint I'm going to apply is a mate constraint, mating the top face of the bottom plate to the bottom face of our top plate. So I've selected those two faces. Now I'm going to select apply. And if I just reorient myself here, we'll see that these two faces are now stuck together essentially. I can still move the top plate around. So you'll see we still have 1 rotation degree of freedom and 2 translation degrees of freedom that we need to constrain. So there's a couple options we could take to constrain these degrees of freedom. We know that the holes in the top plate should be aligned with the holes in the bottom plate. So one option might be to align these axes by applying an axis-axis mate constraint. So let's bring the constraint tool back up. I'm going to press C on my keyboard to bring it up. And I'm going to select the axis of one of the holes on the top plate and the corresponding axis of the hole on the bottom plate to align those two together. So if I exit out of the constraint tool and I just drag this top plate around, you'll see that it still has 1 degree of freedom remaining, which is this rotation degree of freedom that we need to constrain. So we could apply the same axis-axis mate constraint to one of the other holes in our top and bottom plate. Or another option would be to align one of the side faces of our top plate with the corresponding side face of the bottom plate using a flush constraint. So I'll try that next. So this flush constraint is one of the options of the mate constraint. It's this second solution option. So I'm going to select that option, and then I'm going to select the front face of the top plate and the front face of the bottom plate and apply that constraint. And now our top plate is fully constrained. We can't move it around, and there's no arrows indicating any degrees of freedom remaining. So now we can move on to another part in our assembly, such as the bolts. So we know that these bolts should be aligned in the holes of the top and bottom plate, and we want the heads of the bolts to sit in the counterbore holes from the top plate. So if we want these bolts to be aligned in the holes, the first constraint that comes to mind might be an axis-axis constraint. So let's start with that. We'll apply an axis-axis constraint that aligns the axes of these back two bolts to the axes of the holes in the top plate. It might just take some patience to select the axes, but there we have it. We've applied the axis-axis mate constraint to constrain these two bolts. You'll see that these bolts still have some degrees of freedom remaining. If we look at the arrows, which are a little hard to see, here's a good example. We still see that we have a translation degree of freedom because we can move these bolts up and down. And they also have a rotation degree of freedom, so we can rotate these bolts around. Let's tackle the translation degree of freedom first. We know that we want the heads of these bolts to sit in the counterbore holes of the top plate. So what I could do is I could select the bottom face of the bolt head and mate it to the corresponding bottom face of the counterbore hole using a face-face mate constraint. So I'll reopen the constraint tool. I have the mate constraint selected, and I'm going to change my view so that I can select the bottom face of the bolt head. Now I want to select the corresponding face of our counterbore hole, which we can't see from this current isometric view that I'm in. So far I've been pretty much relying on these isometric views to place all of my constraints. In order to make sure that I'm selecting the correct face for this counterbore hole, I can use the orbit tool, either by selecting the orbit tool in the navigation pane or by holding down Shift and the scroll button on my mouse and dragging. So now I can rearrange the view and select the appropriate face to apply the constraint. Then I can do the same for the second bolt. So I'm going to mate the bottom face of our counterbore hole to the corresponding face of the bolt head and apply that. And let's go back to our home view. So now these two bolts are almost fully constrained. All that they have left is 1 degree of freedom remaining in rotation. So the last thing I'm going to do is apply an angle constraint to restrict the rotation of these bolts. So what I can do is I can select one of the faces of the hexagon feature in the bolt, and I can align it to the front face of the top plate. I'll just use the directed angle constraint option, and I'll select apply, and now we've fully constrained this bolt. I'll do the same for the back one, and apply that as well. So now these two bolts are fully constrained. If these bolts did not have these flat faces to apply the angle constraint to, we could have also gone to the origin folder for the bolt, and we could have applied the constraint to one of the origin planes, like the XZ plane. Okay, so those two bolts are fully constrained. We could go through the same process for the front two bolts, where we apply the axis-axis constraint, the face-face mate constraint, and finally the angle constraint to remove all of their degrees of freedom. But let's try something different instead. In fact, let's try something that's way easier. In this case, let's use the insert constraint. So I'm going to navigate to the insert option for assembly constraints. And in this case, I'm going to select the bottom circular edge of the bolt head and the corresponding bolt axis. And I'm going to make the second selection the corresponding edge of the counterbore hole and its axis in the top plate. This will automatically insert the bolt into this hole. And you'll see that we have one other symbol show up when we apply this constraint, which is a circular arrow and a lock symbol. And this is because I have this option of lock rotation checked off in my constraint. So this automatically restricts the rotation of this bolt. We don't have to apply any angle constraint to do that. So we'll apply this constraint. This bolt is now fully constrained using one constraint rather than three. And we'll apply the exact same constraint to the last bolt that we have remaining. So there we go. Our top plate and all four bolts are now fully constrained. Our last step will be to fully constrain the nuts that we have remaining. So let's do one, and once we figure out what we need to do, we can repeat the process on the remaining three. We know that we want these nuts to be aligned with the axis of the bolts. So the first constraint that comes to mind is an axis-axis mate constraint. So I'll open up the constraint tool once more. We're already on the mate constraint. I'm going to select the axis of the nut and the corresponding axis of the bolt, and we'll apply that constraint. That removed quite a few degrees of freedom from this nut, but you'll see that it still has the ability to rotate and translate along the bolt. So we still have to apply a few more constraints. At the end of the day, we want this nut to be placed in this square hole that we have on our bottom plate. So we know that we need to mate the faces of our nut to the faces of this bottom square hole. Again, we'll pull up the constraint tool. We're going to use a mate constraint, and I'm going to select one of the side faces of this nut and mate it to the side face of the bottom plate. We'll apply that constraint. I'll exit out of the constraint tool for now. And if I drag this nut around, you'll see that it's still able to translate up and down. So we have one final constraint that we need to apply. And that constraint is mating the top face of our nut to the corresponding face at the top of this square hole. Again, one final time, we're going to open up the mate constraint, and I'm going to use the orbit tool to select the face of the bottom plate and then the corresponding top face of our nut. And we'll apply that constraint to fully constrain this nut. So there are no more degrees of freedom remaining. We can't see any arrows associated with this nut. We can do the exact same thing for the other three nuts. Now that we've fully constrained the last 3 nuts, our assembly is complete. There are no more degrees of freedom remaining. And if we want to see all of the constraints that we've applied, we can select our entire assembly and select the Show Constraints option, and this will give a symbol for each of the constraints that we've applied. And we can see we've applied quite a few. For now, let's hide those constraint icons, and let's do one more thing. Let's analyze the interference of this assembly. So I've selected all of the components in my assembly. I'm going to go to the Inspect tab and select Analyze Interference. And hooray, there is no interference detected, which means all of our constraints are applied properly. Now, if you do detect interference, that could be because of a mistake in modeling the part or a mistake in applying a constraint. And if it is a mistake in applying a constraint, you can always go back and edit or remove a constraint by going to the assembly browser and clicking the drop down for the part that the constraint is applied to. Here I've clicked the drop down on bolt 1, and we see all of the constraints applied to that bolt. If I want to, say, change the mate 3 constraint, I can right click on this constraint and I can edit it, or I could even go and delete it if I wanted to replace it with something else. This finishes off this example of assembly modeling. So now I encourage you to go ahead and try the other examples on your own.